In this video, we're still going to be looking at organizing and graphing data, but we are going to make a switch over to quantitative data. So now we're looking at data that is numerically based. And so what we're going to go into first as an example, doing a frequency table or relative frequency table, so just like we did before, but with data that is measured numerically, so measured with numbers. And so that presents some additional challenges. If you remember, we did this before. We did it with M&M color, and there were only 6 different M&M colors in the package, so it was easy to list out each possible M&M color. Once you get into data that is numeric, so quantitative, that can sometimes become more challenging, and this is an example of a case like that. What we're asked to do here is to do this for a data set called estimate 10 seconds. And so I'm just going to show you the data here. What I did is I took a group of individuals and I asked them to use the timer on their cell phone to start and then estimate when they think 10 seconds has gone by and then stop and record their answer. So obviously anyone who got it right on at exactly 10 seconds would have a value over here of 10. So here's our data, and you can tell that if we had to list out every value individually, this table would get really large very rapidly. And usually what we do instead is we create intervals, or sometimes those are called classes of values. And so what I'm going to do here is I'm going to set up our frequency table with our variable of interest being our estimate, right? Our estimate of 10 seconds. We're going to have a frequency column. And then we are going to go ahead and add a relative frequency column also, so that we've got both. And what we're going to do for this estimate is we're going to say, okay, well, let's take a look at our data. We'll take a look at the smallest value and the largest value in our data set, and then we'll try to come up with classes that are equal width that represent that data set. So if you take a look over here, it looks like our smallest value was 6.84. And then as we go through, it looks like our largest value was 15.06. And so what seems like it would be reasonable in a case like this is to just go ahead and use classes that cover a single integer value. So in other words, from 6 to, we're only using 2 decimal places, so I'm going to go from 6 to 6.99 would be in that first class. And then from 7 to 7.99, 8 to 8.99, and you can tell we intentionally create each of our classes of equal width here. And we're going to continue that pattern. And now we've got classes that are all equal width. In other words, each of these is going from 6.00 essentially to 6.99, 7 to 7.99, 8 to 8.99. So they're all covering the same amount of space on a number line. And then we're just going to go through and we're going to count frequencies. So how many of these estimates were between 6 and 6.99 seconds? And it looks like there was only one. Yeah, so there was 1 in the 6s. In the 7s, we had 1. Looks like 2, 3, 4, 5, 6 values there. In the 8s, we had 1, 2, 3, 4. In the 9s, we have 1, 2, 3, 1, 2, 3. In the 11s, we have 1, 2, 3 again. In the 12s, I don't think we have any. So in the 12s, we have 0. In the 13s, we have 1. In the 14s, we have 0. And then in the 15s, we have 1. Okay, so we will want to go ahead and add all those up to get our frequency. So I ended up there with 24. And we go on to our relative frequency column, just as a reminder, we're taking each frequency divided by the total. So we would have 1 out of 24, 6 out of 24, 4 out of 24, 5 out of 24, 3 out of 24, 3 out of 24 again, 0, 1 out of 24, 0, and 1 out of 24. Again, that's going to sum to 1, right? And it might be approximate if we got decimal approximations over there, but the sum would be 1. Okay, so that's a frequency table. Also, we put in a relative frequency column to make it a relative frequency table for the estimate 10 seconds data set. And the next thing we're going to move into is, well, how do we then organize that graphically? And so just like we did in qualitative data with a bar graph, we're going to do something similar here in quantitative data with a histogram. So histograms are probably the most commonly used graph in statistics. They're very useful for large data sets. They allow us to see the shape, the center, and the spread of the data set, all visually in terms of looking at the graph. We're going to come back more to center and spread in the next chapter. And then usually, like we said already above here, because we're usually dealing with continuous quantitative data, we're going to group our values into classes or intervals. We already did that. And so that is going to be something that is arbitrary in terms of you creating the graph. You get to choose, but we usually want to create somewhere between about 5 to 15 different classes. Okay, so we're going to go ahead and look at an example of drawing a histogram for the data set that we just put into our frequency table on estimating 10 seconds. So to draw a histogram, we still need 2 axes, just like we did in the bar graph. Our horizontal axis is still going to be our variable of interest. So this is our estimate of 10 seconds. We're going to do something a little bit differently here, and that is that because we did not have classes going from 0 to 1, and then 1s, 2s, 3s, 4s, and 5s, we're actually starting, if you remember, at 6. We're going to put a little break here in the axis, which we just put a little squiggly line to show we're breaking the axis. And then the way that we're going to do this is we typically are going to use the starting value of each class as a label on our horizontal axis. So you'll notice each of our starting values were integer values from 6 to 15. And so we're going to label our axis that way. And then you'll notice I'm going to go 1 value beyond where our frequency table did, and that's because we need a space there to represent anything that was between 15 and 15.99. And if we just stopped at 15, we wouldn't have that location on our axis. And then we'll go ahead and label frequency, and our highest frequency was a 6. and this is for estimate 10 seconds data set, so we're just giving it a title. And then what I want us to realize is that this time, as we're doing a histogram, the order that we put the values of our variable of interest, those estimates here, those times, the order matters, and it's important that we put them in numerical order from smallest to largest. And so, whereas we said with qualitative data, like our color of M&Ms, we could list those colors in any order that we wanted to. Here we need to actually use a standard numerical axis with a scale there. Okay, so our first group from 6 to 6.99, we had a frequency of 1. So we're just going right off the frequency table. Let me see if I can get that up here as well. We'll do that. All right, so our next group from 7 to 7.99, we had a frequency of 6. You'll notice with the histogram, the bars are touching, whereas with the bar graph, there were gaps between the bars. They need to be touching in a histogram because, remember, we are working with numeric continuous data, so there can't be gaps. From 8 to 8.99, we have a frequency of 4. From 9 to 9.99, we had a frequency of 5. 10 to 10.99, we had 3. And then 11 to 11.99, we also had 3. 12 to 12.99, we had none. 13 to 13.99, we had 1. And then we had another gap in the 14s, and then from 15 to 15.99, we had 1 again. Okay, and so that's what our histogram looks like for our estimate 10 seconds data set. One thing I want you to notice that we're going to be doing a lot in future chapters is we're going to be trying to get an overall idea of the shape of this distribution based off of its histogram. So what I mean by that is if we try to kind of fit a smooth curve that goes with this, and you can tell there in purple that this one kind of looks like it's got a low point and then a peak, and then kind of gradually tails off as we go off to the right, to the larger values. And so this one says here, what can we say about the shape, center, and spread of this data set? We're going to look at that more as we move into the next chapter, but what we are going to introduce here really quickly are some common distribution shapes. And so if we fit a smooth curve like we just did, if we fit a smooth curve to a histogram and it looked something like that, this one is called bell-shaped and ends up being an important distribution as we move through the rest of the course. We can also there are lots of distribution shapes. We're just going to talk about a few. The one that you see in the graph we just did looks roughly like this. So it had a rise, a peak, and then a longer right tail. That's called a right skewed distribution. And then if the opposite happens, where we have that longer tail on the left side, you get something like that. That one's called a left skewed distribution shape. So remember, no one is just walking up to us and handing us a distribution shape for our data set. We're taking our data set, we're organizing it into a frequency table. We're then taking it from that frequency table into a histogram, and then fitting a smooth curve to the histogram to see what distribution shape we see. Okay, so those are some of the most common distribution shapes that you're gonna end up seeing. but there are lots of distributions that don't end up being perfectly one of those shapes as well. Okay. The last type of graph here in this section is called an ogive. And ogives are graphs that show the cumulative frequency for a variable. And so we're going to make a cumulative relative frequency table for our estimate 10 seconds data set. In order to do that, we need to create the cumulative relative frequency table first based on our frequency table that we already made, and then we'll draw the ogive. Okay, and so we're going to have, again here, a column for our estimate. And then I'm just going to go ahead and give us a relative frequency column again, because I think it will help you see where the cumulative relative frequency comes from. So again, we had estimates from 6 to 6.99, 7 to 7.99, 8 to 8.99, 9 to 9.99, 10 to 10.99, 11 to 11.99, 12 to 12.99, 13 to 13.99, 14 to 14.99, and finally 15 to 15.99. And our relative frequencies, as a reminder, were 1 out of 24, 6 out of 24, 4 out of 24, 5 out of 24, 3 out of 24, another 3 out of 24, 0, and then 1 out of 24, 0, and 1 out of 24. Okay, so once we have those relative frequencies again written down, then what we're going to find is this additional column called cumulative relative frequency. And in a cumulative relative frequency, we're trying to keep track with how the percentage or the proportion of values grows as we move up in values from 6 to 7 to 8 all the way up through 15s. So initially here, our cumulative relative frequency is going to be exactly the same as our relative frequency, so 1 out of 24. But what we're saying then is, well, what happens by the time we get to 7.99? So by the time we're at 7.99, we've got the one value that we had before plus the 6 new values, and so the cumulative relative frequency is up to 7 out of 24. By the time we get up to 8.99, we're adding 4 more, so we're up to 11 out of 24. In the 9s, we add an additional 5, so that's 16 out of 24. In the 10s, we add another 3, so that's 19 out of 24. In the 11s, we have another 3, which is 22 out of 24. We're still at 22 out of 24 in the 12s. Then we go to 23 out of 24 in the 13s. We don't add any in the 14s, so we stay at 23 out of 24. And then in the 15s, we add our last one and get to 24 out of 24, or 1. Okay, so it's probably going to be helpful here as we move through if we actually have decimal values, so we're going to go ahead and do that. So 1 out of 24 is about 0.042. 7 out of 24 is about 0.292. 11 out of 24 is about 0.458. 16 out of 24 is about 0.667. 19 out of 24 is about 0.792. 22 out of 24 is about 0.917, and then we stay there. And then 23 out of 24 is about 0.958, and we stay there. And then finally get up to 1. Okay, and so the way that we graph those in an Ogive is we still have our horizontal axis representing our variable of interest, which in this case is our estimate. And again, we're going to put that break in the axis. I'm actually going to start this one at 5, and I'll show you why in a second. And we went all the way out to 16, which was our biggest class. And then I'm going to label this cumulative relative frequency. And this is our estimate 10 seconds data set. And again, what type of graph we're doing here is an Ogive. And so our cumulative relative frequencies, we need to go all the way up to 1. So I'm just going to go by tenths. And so what we're going to show here is we're going to just put a dot on the Ogive to represent each of the cumulative relative frequencies. Now some of these do them right on the starting point of each class. Some of them do them kind of in the center of each class. I'm going to just do the center. So in the 5s, we didn't have 5s in our frequency table, and that's because in the 5s our relative frequency was down at 0, but we want to include that as a starting point. So I'm just going to go halfway between 5s and 6s to show that in the 5s we were down at 0. By the time we got into the 6s, we were at 0.042, so not quite 0.05. In the 7s, trying to have you be able to see both at one time. In the 7s, we were at 0.292. In the 8s, we were at 0.458. In the 9s, we were at 0.667. In the 10s, we were at 0.792. In the 11s, we were at 0.917. And then we stayed there in the 12s. In the 13s, we jumped to 0.958. And stayed there in the 14s. And then in the 15s is where we jumped up all the way to 1. Okay, and so if we connect those, usually we use these straight line segments in an Ogive. And come all the way back down. usually we connect at each endpoint to the horizontal axis. So it looks something like this. So you can see where you're building quickly the largest amounts of increase in your relative frequency. And so that kind of shows you that between about this 7 and 10 is where you're starting to get the big increases in frequencies of where those estimates fell. So you can see that a lot of those estimates were in the 7s, 8s, 9s, and then kind of starts to taper off there in the 10s. Okay, so that's an ogive.